computers convert text, images, and sound into binary. Computers can only understand one form of data, binary. Every piece of information processed by a computer, whether text, images, or sound, is converted into a sequence of zeros and ones. This is because computer hardware is built from electronic switches that can be either on, 1, or off, 0. By representing data in binary, computers can store, process, and transmit information efficiently. Text in binary. Text is stored using numerical codes. Each character, such as a letter, number, or punctuation mark, is assigned a unique value in a character set like ASCII or Unicode. For example, the letter A might be stored as the number 65. Once the character is assigned a number, the computer converts that number into binary. When you type a sentence, the computer simply stores a long sequence of binary values that represent each character one after another. Images in binary. Digital images are made up of thousands or millions of tiny dots called pixels. Each pixel has a color, and that color is stored as numbers. A common method is the RGB color model, where red, green, and blue values combine to form a color. Each color channel is usually stored as a number between 0 and 255, which is then converted into binary. A full image is therefore a large grid of pixels, each defined by binary values. In vector images, instead of pixels, the computer stores instructions such as draw a line or fill a shape, but these instructions are still ultimately recorded in binary. Sound in binary. Sound is an analog wave, so computers must digitize it before storing it. This is done through sampling. The computer takes measurements of the sound wave at regular intervals, called the sample rate, and records how loud the sound is at each moment, sample resolution. Each measurement is given a numerical value, and each of those values is then stored in binary. Higher sample rates and higher resolution values produce clearer audio but require more binary data to store. Why compression is needed? Storing raw images or sound would take up huge amounts of space. To save storage and to make downloading and streaming possible, computers use compression to reduce file sizes. Compression works by reducing the number of bits needed to represent the data while keeping it recognizable. Lossless compression. Lossless compression reduces file size without losing any data. When the file is decompressed, every bit returns exactly to its original state. This works well for text and some images. Techniques such as pattern recognition and run-length encoding help remove unnecessary repetition while preserving all information. Lossy compression. Lossy compression removes some data permanently in order to achieve much smaller file sizes. It is mainly used for images, audio, and video because humans cannot perceive every tiny detail. In compressed images, small color differences or fine details might be removed. In compressed sound, extremely quiet or very high frequencies may be discarded. The goal is to remove data that is unlikely to be noticed by the human eye or ear. How image compression works. With lossy image compression, such as JPEG, the image is broken into small blocks. The computer analyzes the colors and gradually reduces precision in areas where changes are less noticeable. In many images, large parts of the picture have similar colors, so these can be stored more efficiently. Lossless formats, such as PNG, look for repeated patterns in pixels to reduce file size without losing visual quality. How sound compression works. For sound, methods such as MP3 or AAC look for parts of the audio that humans are less likely to notice. Background noise, extremely soft sounds or frequencies outside human hearing range may be removed. The remaining data is then packed more efficiently, greatly reducing file size while keeping the audio sounding similar to the original. The importance of understanding binary and compression. Knowing how text, images, and sound are converted into binary helps explain why different types of files take up different amounts of storage. A high-resolution image or high-quality sound file contains far more binary data than a lower-quality version. Compression is essential for streaming, storing media, sending files, and using digital devices efficiently. Understanding these processes highlights the balance between file size and quality and shows how computers handle the vast amounts of data used every day. I thought I should make another because this is fun, and again, Thank you for watching. Like and subscribe, and read this and other articles at my website in the description.